This question here is similar to one of the other SUVAT questions that we did previously. So we have a boy kicking a ball vertically upwards from a height of 0.6 meters above the ground with a speed of 10.5. The ball is modelled as a particle and air resistance is ignored, and it has to be ignored because SUVAT, right? Constant acceleration. If you include air resistance, acceleration is no longer constant because it varies depending on how quickly something is moving. So if we start off, as I always recommend, with drawing a little diagram, doesn't need to be too crazy. So we have a ball, it is 0.6 meters above the ground. It's going up at a speed of 10.5 meters per second. And it has, of course, gravity acting downwards at a rate of 9.81. And as I've said in previous videos and previous questions, this value, it depends on your exam board and the exam paper. I've seen them use 10, I've seen them use 9.8, I've seen them use 9.81. It doesn't really make much of a difference, but they will tell you either in the question or in the paper itself. So it says find the greatest height above the ground reached by the ball. Now, if I throw something up into the air, or I kick something up into the air, imagine it's this pen, it will go up and it will slow down, slow down, slow down, and then it will come back down. And that is the changing direction of the velocity, right? So the velocity is upwards, then it's downwards. In between being upwards and downwards, it has to stop. Okay, so it has to go up, stops, and then comes back down. So at the greatest height, when you project something upwards, that is when velocity equals 0, because for an instant it stops. And if you imagine someone throwing a ball up into the air, you see it slow down, and then you see it come back down. But there's a fraction of a second, a tiny point, where it stops. Okay, so we're looking at some distance up here, and that is when the velocity is equal to 0 meters per second. Okay, and we're trying to work out this total displacement. Now, here's the thing about SUVAT, and it's something that I find that a lot of students struggle with. Remember, it's with constant acceleration. So this ball is going to start 0.6 meters above the ground. So if I plug this all into SUVAT, I do not get the distance that I want. I get the distance minus 0.6 because it starts 0.6 meters above the ground. So in actuality, I'm actually going to be working out that value and adding on 0.6 meters because it says the greatest height above the ground. It's a very fine wording. So I'm going to take upwards as positive. And let's do SUVAT. So S is equal to don't know because we're trying to work it out. U is equal to 10.5. V is equal to 0. A is negative 9.81. And time is we don't know. Okay. So working out SUVAT is probably going to be what will be a good one. V squared equals U squared plus 2AS is definitely one of them using the variables that we have. V is of course 0. So now if we rearrange this, we get S is equal to negative U squared over 2a. And remember to plug this in correctly. The negative is outside the bracket. So some people put negative 10.5 inside the bracket and square it. That's not right. You'll get a negative displacement, which is wrong because that means it's gone downwards, which doesn't make any sense. Over 2 times negative 9.81. If you notice, the negatives will cancel, which is exactly what we expect. So, because we expect a positive displacement. We have negative, open bracket, 10.5 squared over 2 times negative 9.81. Yep, that gives us a value of 5.62 meters. Now again, that's not our answer. That would give us 3 out of 4 marks. So the max height, and I always write it as like a new variable, is equal to 5.62 plus 0.6, which is 6.22 meters to 3SF. And I put that in a big box so the examiner can see it. And again, for 4 marks, I don't think that's too bad. Now, here is where things are going to get a bit funky. If we look at part B, I want to probably draw another diagram because this is where it can get a bit weird. Calculate the length of time for which the ball is more than 2 meters above the ground. And a lot of students find this quite tricky. Now, we could use the exact same layout. Okay? So we could use the same thing. Now, if I draw out the trajectory of this ball, it's going to go up, right? And then it's going to come straight back down. Yeah? And let's say 2 meters is here. somewhere like that. In fact, let me make it a different color just to make it super clear. Let's say 2 meters is when it crosses that line here. So we're going to try and find the time between it crossing 2 meters here and then crossing 2 meters there. So can you see that we're just going to work out when displacement equals 2? That's going to give me 2 times. So let's say it might be 0.5 seconds up and then 1.5 seconds here. So that means it's going to be above 2 meters for 1 whole second, because at time t equals 0.5 seconds it goes above it. At time 1.5 seconds it starts to go below it. So the difference in those times will be how long it spent above 2 meters. So we're going to use basically the same variables, but we're going to say s is equal to 2, u equals 10.5. We technically don't know what v is, because remember, I don't know what v is at 2 meters above the ground. Actually, I've just realised that was close. It's not 2 meters above the ground, but we're going to sub in 2 subtract 0.6, so it's actually going to be 1.4. Because remember, we only have it from when it's 0.6 meters above the ground. So 1.4 meters above, b equals don't know, a is still going to be equal to negative 9.81, and time is actually what we're working out. So this means we're going to be using s equals ut plus half at squared. And this is also another really good point for getting that A star in mechanics, is we should use our logic. I mentioned that there's going to be 2 separate times, right? Because it goes up, comes back down. It's going to cross that 2 meter line twice, right? Now, what equation is going to give us 2 possibilities? Well, it's going to be a quadratic equation. The only quadratic we know with t is s equals ut plus half at squared. So subbing this all in, we get 1.4 equals 10.5t plus a half negative 9.81 t squared. And now what I'm going to do is, we can leave it like this, but I'm just going to rearrange it so it looks more like a quadratic. A half of 9.81 is 4.905, by the way. So it's going to be negative 4.905 t squared plus 10.5t, and then moving the 1.4 to the other side. That was horrible. 1.4 equals 0. And now we're just going to use our calculator to work out the 2 values. And the difference between these values is actually what's going to be the answer. So polynomial degree of 2. And we're going to have negative 4.905, 10.5, and negative 1.4. Gives me 2 answers of 1.9978, blah, 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 blah. Let's leave it to quite a precise degree for now, and then it'd be because it's gone across twice, right? It makes sense that there's 2 solutions. 0.14, let's do 4 decimal places. 0.1429. So what we're saying is 0.1429 seconds afterwards it goes above 2 meters, and then 1.99 seconds after being kicked, it comes back down below 2 meters. So it takes 0.14 seconds to get up to here. Then after 1.99 seconds, it's back below. So hopefully you can see that the total time it's going to be above 2 meters is just the difference between these 2 times, because these 2 times are the points where it actually intersects that. So time above 2 meters. I'm hoping it makes sense as well that the first value is so small. If you imagine kicking a ball, it goes up really, really fast. So it does make sense, right? But then it can spend a long time in the air, or in this case about 2 seconds. So it's going to be 1.9978 subtract 0.1429, and then whatever that answer is going to be our value. So go back to menu, we're going to have 1.9978 subtract 0.1429. I'm not using the answer button because I did round this one. It's going to be 1.85 seconds to 3SF. So again, there's a few little tricks here. So of course, doing this above 2 meters thing, a lot of students don't really know how to do that. So that costs quite a lot of marks. But also, even if they did know what to do, knowing to subtract 0.6 meters is it's not difficult, it's just remembering to do that is quite tricky. Okay?